Solution of first order differential equations by separating the variable. Example 1, dy dx equals to y squared minus x y squared over x squared y minus x squared. So here we shall factorize out y squared in the denominator, so that we have y squared into 1 minus x. Then we factorize x squared in the denominator, so that we have x squared into y minus 1. Therefore, we have dy dx equals to y squared into 1 minus x over x squared into y minus 1. So let me multiply through by dx on both sides, so I remain with dy equals to y squared into 1 minus x over x squared into 1 minus y, then dx. So once I have done this, then I multiply both sides by the reciprocal of, I have y squared over y minus 1. So I want to multiply both sides by the reciprocal of this. The reciprocal of this will be y minus 1 over y squared. And the reason why I multiply through the reciprocal of this on both sides is to get rid of y variable on this side, so that it come on this side. So when I multiply through by the reciprocal of this, which is this one, then I will have y minus 1 over y squared dy would be equal to 1 minus x over x squared then dx. So at this point I have separated the variables, x on one side, y on the other side. So once I have separated, then the next step is for us now to integrate the given expression. So we shall have the integral of y minus 1 over y squared dy equals to the integral of 1 minus x over x squared then dx. So we can rewrite this one as the integral of y over y squared dy minus the integral of 1 over y squared dy equals to the integral of 1 over x squared dx minus the integral of x over x squared then dx, like that. Let me run this. So this y here 1, it goes with one factor of y, so that we remain with the integral of 1 over y dy, and then minus the integral of this is the same as y raised negative 2 dy, then equals to the integral of this is x raised negative 2 dx, and then of course we have minus the integral of one factor of x goes with one factor there, so that we remain with the integral of 1 over x then dx. So here we integrate 1 over y, get ln of y minus, when you integrate this, when you integrate y raised negative 2, get minus that, we shall get y raised negative 2 plus 1 over negative 2 plus 1, like that, equals to, when you integrate x raised negative 1, we get x raised negative 2 plus 1 over negative 2 plus 1, then minus, integrate 1 over x, we get ln of x, and of course plus a constant of integration, plus a constant of integration. Now this will be ln of y minus, so this will be y raised negative 2 plus 1 and y raised to negative 1, then minus 2 plus 1 would make negative 1, so we shall have negative y. We shall have negative y equals to, here we shall have negative x, so it's negative 1, then minus ln of x plus a constant of integration. So here we shall have ln of y, negative positive, so plus, then this is the same as 1 all over y equals to minus x minus 1 all over x minus ln of x, then plus a constant of integration, plus a constant of integration. Okay, example. Let's go to example 2. Example 2, we have xy dy dx equals to x squared plus 1 over y plus 1. So how do I separate the variable? Let me divide it through by x, so that you have y dy dx equals to x squared plus 1 all over y plus 1, then x. Then I multiply through by dx, so that I have y dy equals to x squared plus 1 over y plus 1, then x, then dx, we multiply through by dx. So how do I get rid of y plus 1 on this side? I multiply both sides by y plus 1. So if I do that, then I have y into y plus 1 dy equals to x squared plus 1, then dx, but remember we have over x. So at that point, you have separated the variables, x on the other side, y on this side. So at this point, you can now integrate the given expression. So we have the integral of y squared plus y dy equals to the integral of x squared plus 1 over x, then dx. Now integrate. So here when you integrate y squared, get y cubed all over 3 plus y squared all over 2. When you integrate y, get y squared all over 2 equals 2. But before we integrate it, remember this is the same as the integral of x squared all over x dx, then plus the integral of 1 all over x dx. So which is the same as, here is the same as, this goes with that x, so it's the same as the integral of x dx, then plus the integral of 1 over x dx. So when you integrate x, you get x squared all over 2. When you integrate 1 all over x, you get ln of plus ln of x, of course, plus constant of integration. Thank you for watching and listening.